So the previous class we have seen primitives of IPC, inter-process communication. Basic primitives ఏమున్నాయి వాటికి సంబంధించి previous class లో మొత్తం చెక్ చేశాం. Now today, so I'm going to take some very important concept to you, how inter-process communication will be done via locks. లాక్స్ ను వాడుకొని ఎలా మనకి ఇంటర్ ప్రాసెస్ కమ్యూనికేషన్ ఇక్కడ వర్కౌట్ అవుతుంది అనే విషయాన్ని క్లియర్ గా మాట్లాడదాం. సో ఇంటర్ ప్రాసెస్ కమ్యూనికేషన్ లాకింగ్ మెకానిజం, totally 2 different types of locking mechanism is available with inter process communication. One is mutex and the second one is the semaphore. ఈ రెండింటి గురించి క్లియర్ గా మాట్లాడదాం. So let us go ahead with mutex locks. Mutex ante what is mutex actually? What kind of things are being happening here, and what kind of activities or advantages or disadvantages of mutex? Let us see. So mutex in the sense mutual exclusive locks. That is the mutex here. Mutual exclusive locks here. MUTEX. And what does it means? What exactly you are supposed to specify this one is only 2 different processes will be entered into mutual exclusive. Not 2. Many processes will be entered into mutual exclusive locks, but only one process will be acquire the lock. Remaining every process will be under waiting mode, continuously waiting mode. So this is the basic issue regarding to mutex. Mutex సంబంధించి number of processes. అంటే mutex is a variable. It is a binary variable. That variable could be able to store either it is 0 or it is 1. ఒకటి కానీ 0 కానీ so మాత్రమే ఉంటుంది. If 1 will be there, then the mutual exclusion kind of lock is being available. So already occupied by some other process. 0 will be there. Yes, this lock is available for open, and some other process will be acquired. ఒకటి ఉంటే వేరే వాళ్ళు ఆల్రెడీ హ్యాండిల్ చేస్తున్నారని, 2 ఉన్నట్లయితే 0 ఉన్నట్లయితే సో దట్ ఈస్ నాట్ బీయింగ్ హ్యాండిల్డ్ బై ఎనీబడి, ఎవరి ద్వారా హ్యాండిల్ చేయట్లేదు, అవైలబుల్ గా ఉంది, వేరే వాళ్ళు ఎగ్జిక్యూట్ చేసుకోవడానికి అవకాశం ఉంది. So what is the basic issue here? We'd like to implement this one here in the sense to execute the critical section in a proper way. Critical section in a proper way lo enter cheyadam kosam denni mutex introduce chesam. So mutex, so before going to enter into the critical section, that you have to take the mutex. తీసుకోవాల్సి ఉంటుంది. ఈ mutex దేనికోసం వాడతారంటే to prevent the race conditions. Okay. సో అన్కమిటెడ్ కైండ్ ఆఫ్ డేటా ఏదైనా ఉన్నట్లయితే ఆ డేటాని ప్రివెంట్ చేయడం కోసం ఎక్కువగా మ్యూటెక్స్ ని వాడుతూ ఉంటారు. దట్ ఈస్ ద బేసిక్ ఇష్యూ విచ్ వీ హ్యావ్ టు కన్సిడర్ ఇన్ టర్మ్స్ ఆఫ్ మ్యూటెక్స్ హియర్. దెన్ వాట్ ఈస్ ది యాక్చువల్ మెకానిజం? ఇట్ ఈస్ వెరీ సింపుల్. సో బిఫోర్ గోయింగ్ టు ఎంటర్ ఇంటు ది మ్యూటెక్స్ critical section, you are expected to acquire the lock. You are expected to acquire the lock. So then after execution has been completed in the critical section block, then you have to release that particular lock. These are the 2 different basic fundamental operations which have been implemented with mutex. Okay. One moment please. Okay. So if before going to enter into the critical section so area within that particular code, you need to acquire the lock of the mutex. Without acquiring the lock of mutex, so it is highly impossible to access the critical section area where exactly there within your program. Okay, that is first one. After execution of your critical section, then you have to release that particular lock which is used by some other people. Okay, so that lock must be released. These are the two different basic or fundamental operations which could be done by mutual exclusive kind of locks here. Okay. So here, what exactly the things will be? So it could be the general idea how the mutual exclusion could be gets included here or implemented here. So while true, true, acquire the lock, you have to acquire it. So we'd like to give what is this acquire here? What is this acquire? We'd like to give after this particular process will be gets succeeded. That is, the lock has been acquired by you successfully. Then you will be permitted to execute your mutual exclusion. If acquire cannot be done by your process, you never enter into critical section problem. So therefore, we could understand that only one process will be executes its critical section. No other process will be entered unless otherwise it may be acquire the lock of that particular critical section here. After completion of this particular critical section, then you have to release the lock. So lock release in the sense, let me say the mutex value will be initially equal to 0, for example. So process 1 is trying to process 1 and the process 2, two processes are there. Of course, many processes must be here. Two processes are available here. Process 1 is trying to acquire the acquire the mutex lock. Yes, it could be because already mutex value is 0, so it is not handled by any other process. So it could be make this particular value into 1 here. So obviously, whenever it could be gets 1, obviously, so no other process is trying to access this mutex. Already it is 1, so therefore they will be in continuous deadlock. They will be in continuous deadlock. Now, lock was acquired by P1, so therefore critical section can be gets executed. Then after completion of this critical section, it could be release the lock. So again, this 1 will be converted into 0. When 0 will be there, obviously another process will be have a chance to get the lock, mutex lock, for enter into the critical section here. Then you have to finish up your problem and you will leave the particular critical section over there. So this is the general idea how that particular process will be going on within the within this mutex kind of operations. So look at this. It is a Boolean variable having two values. Either it is 0 or 1. So available. One more operation is there, that is available. Available is going to be taken into consideration. This available could be taken either it is 0 or 1 here. So within the mutex, if it is 0, that is false, then you could not get the process here. If it is 1, so you could not get anything here. If it is 0, you can access the particular critical section. If it is 1, you couldn't do it. Okay. So that is what. If available will be equal to true, so lock is available to access to acquire. No other, and then no other process will be enter into critical section here. Let us see what are the different activities of acquire and so here release here. Acquire while not available. So if it is available will be equal to true in the sense, not available will be equal to false. So immediately your while loop will be gets over. Your while loop will be gets over. If available will be equal to false in the sense, not false in the sense, it could be always true. It could be gives you always true. So while true, while true, while true. So obviously your process will be in a continuously waiting state until the process which is being executed, its critical section. So that is the point here. As and when this this particular thing, this while loop is being exited out, then immediately true will be, 0 will be, 1 will be modified to 0, or true will be modified to false. Okay. Release in the sense, obviously, so available will be made into true. Okay. Now there is a new word which is going to introduce for this mutex, that is, I have given this one again. So that is spin lock. SPINLOCK. Spin lock. Okay. So continuously available false undunnam. Continuously available false only. Number of processes So available, the variable available will be having so false for huge amount of time. Process 1, so process 2, so process 3, and so on and so forth. Many number of processes have been accessing this particular available. So not available equal to true. So since not available equal to true, this particular area will be never ever gets exited. So that will be indefinite loop. So since it is indefinite loop, all processes are trying to access the available variable continuously. The processes will be waiting at the available variable. So that is why it is called as a spinning towards that particular while loop. So that could be called as a spin lock. Mutex could also be called as a spin lock. Continuously sensing this available. Okay. Then disadvantages. What are the disadvantages? No advantage at all. Disadvantages. What are the disadvantages? Is acquire. In this acquire operation, if one process will be taken, the mutex, and remaining all processes will be must be wait for a huge amount of time. There is no chance to perform other operation other than critical section because you have been aspirant. You are an aspirant to access the available, that is mutex. So that is why you will be put into ready queue for your execution. So it could be take huge amount of time. Okay. Then if any process will be under critical section, some process 1 will be executing its critical section. At this particular point, some other processes will be so taking that one, then it will be loop will be continue for huge amount of time. So these are the. However, whatever the statements I have given here, both statements will be so represents busy waiting, continuous waiting. That's all. Okay. So when it could be terminated, already critical section will be executed process will be complete and available will be so modified with the false to true. Then it could be released and one more process will be entered into so-called critical section, and remaining all other processes who are waiting over there, they will be under so as usual, that is waiting state only. So this is the basic disadvantage, and of course this is also called as a binary log because we have only two values, either it is true or false or it is 0 or 1. So because of that reason, this is binary log. No other kind of implementation for mutex here. So this is the basic problem here. To evaluate or to implement this binary log to some other log, so semaphores have been introduced. So semaphores was actually introduced by Edgar Dijkstra, so who were actually introduced single source shortest path algorithm was also introduced by so Dijkstra only. So you people have learned that particular algorithm in your design also of algorithms. So however that particular semaphores was proposed and introduced to the world by Dijkstra only. So that particular semaphore has been used by all operating systems today to execute its critical section. Okay, look at this. Semaphores does have the two different fundamental operations: wait and signal. Wait and signal. Okay. The process of waiting is being stipulated something like this. So here there are two different types of semaphores are available. What I am trying to discuss at this moment, it is called as a binary semaphore. Binary semaphore, and of course this could also be applicable for counting semaphore also. It could also be accepted for counting semaphore also because the condition has been framed in such a way. Condition has framed in such a way. So that is why it could be accepted for counting semaphore and binary semaphore. Let me give you. So I'd like to take both. So here S is the variable for semaphore. Semaphore is normally represented with capital S. It is a global integer. It is a global integer. By default, semaphore will be allocated or given to each and every resource type. Basically, Inter-process communication is always trying to concentrate on resources and execution of critical section. These are the 2 points. So far, we did not consider the resource point in this discussion of what do you call, inter-process communication, otherwise a critical section problem are there. So here, semaphore will be assigned to both the critical section problem and at the same time resources also. So some resources are having huge number of components. Some resources cannot have so huge number of components. For example, let me consider printer. So if you have so only one printer at your office, so this printer number of resources of a printer type will be 1. Okay, it will be comes under binary semaphore type. Binary semaphore type. Already one job is being taking the printout using that particular printer. Remaining all other jobs must be under queue to get the printout from that particular printer. So therefore, one job is being taken by process 1, and the critical section is getting printing is the critical section. So remaining process will be waiting mode. If you consider memory cycles, CPU cycles, not memory cycles, CPU cycles. CPU cycles in the sense, so huge number of CPU cycles will be there. So 2.33 gigahertz number of CPU cycles will be there. So the count of this particular semaphore will be 2.33 into 10 power 12. Okay, 10 power 10, not 12, 10 power 10. 10 power 12 is beta. So, okay, so 2.33 into 10 power 12 will be the 12 will be the semaphore value. So, for example, my process will be required some 1,000 CPU cycles to execute. So, 1,000 will be allocated. So, semaphore value will be reduced by 1,000. Okay, and so on and so forth. Use multi-programming, parallel programming system is being running. Then all CPU cycles will be get over. It may be reached to 0. It may be reached to. So many number of processes are being executed. Then they will be reached to 0. So whenever resource type value will be reached to 0, then you have to wait for some more time. Okay. Here also memory also. If you consider the memory, so 1 terabyte of memory will be there with you. So let me consider each and every gigabyte will be 1 unit. For example, for my convenience, for our convenience, 1 gigabyte will be one unit. Then we have to consider 1024 gigabytes will be available within that 1 terabyte. So if a process will be required 2 gigabytes, just allocate it. So after 2 gigabytes will be allocated for a process, semaphore value will be decreased by 1022. One more process will be required some 22 gigabytes, allocate it because already available, allocate it. Semaphore value will be reduced by 1000. Okay, like this, in terms of counting, in terms of what do you call binary. Binary in the sense only simple kind of resource which is under non-shareable mode. Printer cannot be shared by many number of people. It is highly impossible to share. Okay, so that is why printer is not in share mode. Therefore, thereby the semaphore will be called as a binary semaphore, and so CPU cycles, these are huge amount of CPU cycles will be there, huge amount of space, memory space will be there, huge amount of microprocessor cycles will be there. So thereby counting semaphore will be comes into the picture. Okay, for both these implementations could be done here. This could be valid for binary, and this could be valid for binary and both. Okay, in this way it is going to be evaluated. When S value is goes to 0, then other process is waiting for that resource for execution of so-called critical section, and it will be put into waiting mode. Okay, waiting mode is common, but semaphore will be allocated. The value of semaphore will be allocated for resources as well, including the critical section. It is going to allocate it for resources as well. Okay, so that is why it is having highest priority to use within the implementation of operating systems. Okay, so I hope that you got the point. So that is what the point which I have given here. Binary semaphore and so counting semaphore. Counting semaphore in the sense when so 1 TB of memory will be there with you, and if you reduce 50% of memory, obviously it could also be reduced 512 gigabytes. 512 gigabytes will be half TB. 1024 gigabytes will be 1 TB. Okay, if you reduce something, obviously the semaphore value also be reduced. Okay, if you increase the so specific resource, obviously semaphore, you need not to open any settings or configurations to set the value. Obviously, based on the semaphore value of that particular object, obviously it is being increased and it is being reduced. There is no problem at all. Automatically it is being happening. That operation will be taken care by operating system itself. We need not to open any configuration file or any initialized file to be perform the operations. So that is the importance of semaphore. So therefore, semaphore will be also concentrated on what do you call it? Resources. Allocation of resources would also be comes into picture while critical sections are being done here. So this is what the class could be. So I shall continue tomorrow. So let me open one more. There is no other slide also with me. Let me open. So here we have completed inter-process communication. Inter-process communication completed. Now tomorrow, what is live lock and what is deadlock, and how starvation will be get secured in deadlock. So will be discussed by tomorrow. Live lock అంటే ఏంటి, డెడ్లాక్ అంటే ఏంటి, స్టార్వేషన్ ఎలా వస్తుంది, వాటికి సంబంధించిన ఇష్యూస్ మొత్తం కూడా డిస్కస్ చేస్తాను టుమారో. ఓకే, థ్యాంక్ యూ. సో 25 minutes ఓన్లీ నేను స్టార్ట్ చేసి. సో ఇవాళ అంత స్టఫ్ లేదు, క్లాసెస్ ఎక్కువైనాయి, వేరే వర్క్ కూడా ఎక్కువైంది, అందువల్ల కొద్దిగా ఇబ్బంది అయింది. సో టుమారో ఐ షాల్. Thank you for your patience. Let me take attendance of you. 27 people have attended. Okay. Thank you.